If you remember from our first unit of study, I told you that we have a set of numbers called the real numbers that include rational, irrational, integers, naturals, and whole. At that time, I told you that every single number you encountered was a real number. Well, now I'm going to tweak that definition a little bit and tell you there's also a set of numbers called imaginary numbers. So here's how imaginary numbers work. If I start looking at some square roots, if I ask myself, what is the square root of 36? Well, since 6 times 6 is 36, I can say the square root of 36 is 6. I can also say, since negative 6 times negative 6 is 36, that the square root of 36 is negative 6 as well. Oftentimes you'll see us say the square root of 36 is plus or minus 6 for that reason. If I continue looking, I can say, well, the square root of 16 is 4, since 4 times 4 equals 16. I can say the square root of 121 is 11, since 11 times 11 is 121. I can say the square root of negative 49. Maybe I say it's 7. Well, no, I know 7 times 7 is 49 positive, so that didn't work. Maybe then it must be negative 7. Well, since negative 7 times negative 7 is also positive 49, that doesn't work either. So how do I take the square root of negative 49? Well, mathematicians ran into that problem, and so they decided, let's create another subset of numbers called the imaginary number system. We'll call the imaginary number I, and we're going to let I equal the square root of negative 1. That then allows us to take square roots of negative numbers. So if I equals the square root of negative 1, then I squared must be the square root of negative 1 times the square root of negative 1, which equals the square root of negative 1 squared, or just negative 1. If I look at using this new imaginary number to simplify, notice that in my first expression here for letter A, I have 3 minus 4i squared. Well, isn't that 3 minus 4 times negative 1? Since I squared equals negative 1, well, that then gives me 3. Negative 4 times negative 1 is plus 4, or 7. If I look at letter B says the square root of negative 4. Well, here's how I'm going to look at this. I'm going to think of this as the square root of negative 1 times 4. Well, I know that the square root of negative 1 is I, and the square root of 4 is 2. Therefore, the square root of negative 4 is 2i. Similarly, if I look at the square root of negative 64, I'm going to think of that as the square root of negative 1 times 64. Well, I know square root of negative 1 is I, and the square root of 64 is 8. So I'm going to go ahead and say that this is then 8i. So notice, based on examples B and C, if I have a negative underneath a radical, I need to make sure that after I take the square root, I attach an I to whatever I get. Looking at letter D. So again, I'm going to say negative 2i. Well, I don't know how to simplify I. I just know it's the square root of negative 1. There's not a lot else I can do with that. That cannot be simplified any further. Since changing this I here to the square root of negative 1 is not going to allow me to simplify anything further, I'm going to leave it as an I. However, that I squared, if I change that to negative 1, that then allows me to multiply it by the 5, giving me negative 2i minus 5. So notice that in number 1, after simplifying, or in letter A after simplifying, I came up with a real number. In letter B after simplifying, I came up with an imaginary number. It just has a coefficient of 2. In letter C, I also came up with an imaginary number with a coefficient of 8. In letter D, I came up with both an imaginary part and a real part. I'm going to talk in just a moment what that means. But before I do, I'm going to complete these by looking at letter E. Letter E becomes negative 3 plus, well, I know the square root of 9 is 3, therefore the square root of negative 9 should be 3i. And there's nothing more I can do to simplify that, because very similar to letter D, I cannot simplify an I by itself. So once again, I came up with a real part and an imaginary part. So notice it's fairly common for that to happen. For that reason, we come up with something called the complex number system. A complex number system is going to be numbers composed of both a real part and an imaginary part. They are usually written a plus bi, so we always rearrange them to put the real part first and the imaginary part second. So we have our real number system composed of rational numbers, irrational numbers, integers, whole numbers, and natural numbers. And we have our complex number system that's composed of imaginary numbers and real/imaginary numbers, or complex numbers, what they're called when they look like this. So let's look at graphing complex numbers. So just like imaginary numbers, they can be graphed. When we graph them, we are going to have an xy axis. The only difference is our x-axis is going to be called the real axis, and the y-axis is going to be called the imaginary axis. So otherwise everything gets graphed the same. So if I'm graphing 3i minus 4, I notice that if I were to write this in the form a plus bi, I'd have negative 4 plus 3i, because it does not matter what order we add and subtract in. The commutative property tells us that. So this tells me to go back 4 on the real axis, 1, 2, 3, 4, and then go up 3 on the imaginary axis, 1, 2, 3. So here would be my point, negative 4 plus 3i. I'm going to do each of these in a different color. If you are using the same color in your notes, make sure you label them. If I look in red at this next one, 5 plus 2i, this tells me to go forward 5, 1, 2, 3, 4, 5, and go up 2, 1, 2, putting me in the first quadrant of my imaginary axis. And I kind of missed my mark a little bit there. Looking at the third example, negative 5i. Well, if I want to graph I'll do that one in green. If I want to graph negative 5i, so first let me underline this in red so we know that's the red one. Okay, so if I'm going to graph this one in green, this tells me to go left or right 0. I have no real part, but the imaginary part tells me to go down 5. 1, 2, 3, 4, 5. And then graphing the last one, let's see, I'll graph that one in blue. I'm going to go back 2 and down 4. 1, 2, down 1, 2, 3, 4, putting me in the third quadrant. And there's my negative 2 minus 4i. I'm going to go back and label them. I didn't know if I would have room to label them with my graph because I really should always label my points. 5 plus 2i. Okay, and so there's are my four points in quadrant 1, quadrant 2, quadrant 3, and then on the imaginary axis. And those are imaginary and complex numbers.